Thank you for coming out on such a crappy night. Cold, crappy night, but I think you're going to be very entertained tonight. Just following up, Ron gave us a talk 2 years ago.
2 years?
About 2 years ago. And Ron has been a regular at our Wednesday night experimenters nights and has beavered away on a huge range of things, which he'll go into tonight, and has moved his experimentation in the radio control arena leaps and bounds in that time. And so one of the reasons why I really wanted to get Ron back to give us a bit of an update on where he's at, but also the sort of radio controlled technology that is available these days is just mind-boggling. So I'll hand over to Ron and go for it, Ron.
Okay, thanks Justin, and thanks to the Reast committee as well for giving me another opportunity to speak on a hobby which I really love. It's great that we're live streaming, so I've got a few friends and relatives around the country and the world which hopefully will be tuning in. So I'd like to give a shout out to my dad over in Western Australia. Hopefully he's tuning in. My son's in Dublin in Ireland, so he might be tuning in as well. And I've got a daughter in Queensland, Bundaberg and Melbourne. So hello to you if you're watching. Who is a pilot? Yeah, commercial pilot. Yeah, and brothers and friends all around the place. So, okay. So as you can see, radio control technology. Bit of a layout of what we're going to be doing tonight. So an introduction, and I'm going to talk a bit about safety. A few things after researching it, I learned a few things in it, so it's pretty good. A review of my last presentation, which Justin said was about 2 years ago, and a few findings from the last presentation. I got some really good suggestions, and some of the questions that people asked on the last one actually steered me into things that I've done now and which I want to show as well. A bit of new stuff that I've been working on, and where to go after this. And for the people that are live streaming and not sure where we are, we're in that little building there. It's located on the Queen's Domain down here in Hobart. I think it's about 10 degrees outside and raining. Not looking like that at the moment. Just a quick little bit about me. This is a slide I used last time. I learnt to fly back in 1979. Started with the traditional fuel-powered balsa planes, flying line of sight. And here's an example of one that I used to fly. This used to have a fuel glow plug engine on it, and I've converted it over to electric. And that's built that from the plans. That's just balsa wood and foam wings. When we moved to Tasmania in 1998, I sort of stopped flying. I suppose I was a bit busy with my new career and everything like that, and didn't actually get back into it until a few years ago, about 3.5 years ago, and couldn't believe how much things had changed over that time with all the FPV and flight computers that you can put in planes and drones and all that sort of stuff. And yeah, it just blew me away, so I got back into it again.
Decode for FPV?
First person view. So it's where you're using goggles with the camera on the plane. Yeah. I brought in my original radio transmitter, which I bought back in the 70s. So this is all in separate components, no integrated circuits or programmable chips or anything in here. It was originally 27 megahertz. Needed to be modified for 29 megahertz. But so it still works, but I don't use it anymore. Now, Mike's brought in some old equipment, which he's going to talk about a bit later on. It goes right back to the 50s or something, isn't it?
1950s.
1950s. Predates all of this, so stick around for that, and that'll be interesting. Right, so we'll get on to a bit of safety, and people would have heard of CASA, the Civil Aviation Safety Authority. So that's the government body that regulates all this. And it's a good thing, and they're having a bit of an influence, because we would have all heard about the drone flying near airports and stuff, especially the Heathrow Airport, you know, which shut down aviation for a few days from there, which just affected the whole world. And also, even down in Tassie, the Christmas Day bushfires on Bruny Island, there was someone flying a drone around Bruny Island wanting to have a bit of a gander, and they had to evacuate the helicopter and all that sort of thing, so that upset all that sort of thing. As well as that sort of flying and safety, there's a safety with the models themselves, and then pretty obviously you've got propellers flying at high speed, which can be dangerous, and batteries. I've got a bit of information which I'm going to share with batteries. The Lipo batteries can be quite hazardous as well. So I've got a short video off the Drone Flyer website, which I got from CASA. So I'll just quickly play that.
Drones are fun to fly, but you must fly responsibly to keep other people in the air and on the ground safe. And it's vital you follow these simple rules. You must fly in daylight, operating one drone at a time, making sure it's kept in your visual line of sight. Don't fly in areas where your drone is above other people and be at least 30 metres away. This could include beaches, parks, events or sports ovals. You mustn't fly higher than 120 metres or 400 feet. That's about the length of a footy field. And don't become a danger to other aircraft, so keep well away from aerodromes and helipads. If you see an aircraft nearby, land your drone immediately. You must stay well away from emergency services like police operations and firefighting. Obey the rules as there are heavy fines, and always respect other people's privacy. Visit droneflyer.com.au for more information about these rules and where you can and can't fly. And download CASA's free app, Can I Fly There? Have fun, but fly responsibly.
Okay, anyone seen that one before? Yeah, it covers all the bits and pieces on it. It's quite good. The app's quite interesting too. I'll put that on my phone, and yeah, it goes to big red areas where you can't fly, so it's that's quite good. Now, I'm using Google Slides for this presentation. It's a little bit quirky, so hopefully things will work out okay. Right, the next slide I've got is the safe storage of Lipo batteries. So I've got a short video on that. Already it's a bit ominous, isn't it? So what they're doing, if I'll pause this, they're using what they call a Lipo Safety Bag, so lithium polymer batteries. They're storing the batteries in the bag, and they're simulating a failure. I think what they're doing is they're overcharging them with a fair bit of voltage, fair bit of current, and just seeing what happens. So this one is, these are the smaller batteries in this bag. That's a Lipo battery bag. And you can see when the battery ignites or fails, in this example, it's emitting a lot of smoke. Oops, stop that. But it didn't actually catch fire. So it was all contained in the bag, which is a good thing. All the batteries were destroyed. A lot of smoke damage. The floor was damaged because it was a lot of heat. And the tip, if you're using a Lipo safety bag, only use small Lipos in it. The next one, they put a really big Lipo in it. It's a 16,000 milliamp one. This one here is a 3,000. Same sort of thing. You can see they're overcharging it. So it takes a while. They've got it sped up, and you can see it's starting to expand.
The battery getting fat.
Oh, I think it's
Is it the gas or whatever?
it might be the gas, yeah. And then you can see it goes off, and it's just total destruction, and a lot of flame and everything. So you also got to be mindful of where you're storing these in your house. Not a good idea to keep them in the house.
Is the Lipo bag some sort of fire retardant?
Yes, yeah. Yeah, so do not use with big batteries. Total destruction. Now, what they do is they use do a few tests with ammo boxes, and I brought my ammo box along. And with this one, they've got the lid open, as you can see. When the Lipo fails, catches fire, but the fire is fairly contained with it in the box, but it's it's coming out of the opening. So that's still not a real safe thing to do.
A lot of batteries in there.
A few batteries in there. And you can see the this test is done outside, and the wind's blowing the flame around. You can see the flames just caught fire to everything. So it doesn't work very well. Damaged floor, smoke damage, likely to burn everything down. The next test, or the last test now, which I've got, is a ammo box with the lid closed, and they've removed the seal. So if you didn't know, with these ammo boxes, they have a rubber seal that goes around the top. So when you're storing ammo, it keeps it waterproof. But what they've done with this one is they've removed the seal. The battery's failed. It's allowed the gases and smoke to come out, but no flame. You can see it spewing out the corner there.
So you've removed the seal on there also.
I have, yeah.
Did you do
After
that?
doing this.
After
seeing this, yeah.
Right.
So one of the best options with that one, still got very hot, so it damaged the floor and everything like that. It didn't create a fire to burn everything down. So I now have my seal removed. I used to have the seal in there. They did have one, I didn't bother putting it on, with the seal in there, and as you can imagine, it builds up an immense amount of pressure. It all distorts and everything. The example that they had, it didn't explode, but it could have exploded. So it's best to keep the seal out. Now I do that. And I keep these outside of the house. I don't leave them in the house. Okay. Right, so there's storage ones. I've got another little short video, and this is a few mishaps that can happen with Lipo batteries. So don't try this at home. F11. Already it's a bit he missed it, hit the battery. I'll just pause that a second. So what happened in the, I'll go back a bit too. I stopped that one because all it does in the video for a few minutes is it just smokes and smokes and smokes. It doesn't catch fire or anything like that. So I thought I don't need to watch any more of that. So continuing.
No para, sacá en mi caso, sacá la hélice. ¡Oh, boludo! Te dije que no para. El matafuego, el matafuego. El matafuego. No para nada, ahora está bien. No para. Tengo un matafuego, no. Reventó, coño.
That music. Yeah, so fairly dangerous. You need to be careful with them. Now the Lipos, because they're multi-cell, overcharging them will cause what you saw happen there. So each cell nominally has about 3.7 volts. So I've got 4-cell battery here and a 3-cell battery. The maximum they should be charged to is 4.2 volts, and the minimum they shouldn't be discharged any lower than 3 volts. Otherwise you can damage the cell, damage the battery, and they're fairly expensive to buy, so it's best to look after them. And that's what all these little lights are hanging off here. They're battery monitors, and they're just keeping an eye on the cell voltage. So as I'm using them, if you discharge the battery too far and the cell starts to get down to the dangerous area where it can be damaged, this will alarm and it'll start flashing, so you know that, stop using that battery, put it on charge. So, and for charging them, you need a special charger, a balance charger, which I've got here. This is the one that I've got. This one just plugs 12 volts in on the side, and you have your charging port which plugs in, and as it charges it monitors each of the cells so it doesn't overcharge them, because you don't want to have those fires happening. So you'll need to get a Lipo balanced battery charger as well with these sorts of things. Right.
Are these different to the sort of cells we have in our telephone?
Lithium ion we have in the
So
phones.
these
These are
ones
lithium polymer. These are more
catch fire.
dangerous. I think they do. Remember the Apple things where some Apple phones were catching fire and there's a few years ago? Yeah, I think they were a faulty batch of batteries, but I think they all need to be treated with caution. Okay, so the next thing are some findings from the previous presentation done a couple of years ago. We discussed about the advantages and disadvantages of having a plane with a rear propeller and a forward-facing propeller. So the rear propeller is better for any camera work which you might be wanting to do, because with the propeller in the front, especially if the camera is right up close to the propeller, when it's turning you get the strobing effect of the propeller, and it can be quite off-putting. And I had a video which I showed the last time. It's almost unbearable. Someone asked a question about switching video and having multiple cameras on the plane, and that's one of the things which I've done. This plane here actually has 3 cameras in it. A standard definition camera on this side at the front, a high definition one here, a GoPro, and another camera on the top here. Now I've incorporated a little video switch in there, and I'll be demoing that a bit later on, where you can switch between a front camera and this other camera up here. VASI. VASI stands for Visual Approach Slope Indicator. It's what aircraft use when they're coming into land on a runway, and it gives the pilot a visual representation of where they are coming down to land. I tried to make one of them and it was unsuccessful. Actually, that's the next slide. With the rear propeller, when you go to launch these, if you throw them, you've got a propeller spinning there, you can actually do damage to your arm. So I built a launching ramp, which I'll be talking about. I've got a little video about that. And the little thing I called the Easter Challenge. Back in 2017, I was new to this. I put it all together and gave it a go on Easter in 2017. And I want to talk a little bit about that as well. Right. So this is the VASI, and you may have seen these or might be wondering if you're in an aircraft that's taxiing to take off. I took this photo in Sydney, and unfortunately the VASI hasn't come out all that well, but it's around about there. There's a bunch of lights going along there, and the diagram on the side there is just representative of 2 lights. When an aircraft's coming into land, if they're on the glide slope, typically 3 degrees, they'll have half will be red, half will be white. If they're too high, by the way the lights are set up, they'll get white light, so they know that the pilot know has to come down to get onto the glide slope for an optimal landing. And if he's too low, he's got red ones, so that's not a good thing. So I noted when I'm coming into land, if I'm wearing goggles, I was overshooting, or it's really hard to pick a good landing spot, harder than I thought it would be. And I thought, no, what, I'll make a VASI. So I got this box and put really bright LEDs and red perspex and clear perspex and set it up. It didn't work because the camera just didn't have the resolution. I could hardly see the box, let alone see the lights. So. Right, the launching ramp, which I designed. I tried to find some measurements on the internet. I couldn't, so I just made it up myself. On the previous presentation I showed, I started with little drinking straws just to make a little scale model and work out angles and stuff until I finally come up with using this dowel. So here's a little short video of a takeoff. Now, another safety thing with these aircraft is most modern drones will have, with your radio transmitter, you'll have an arming sequence which you need to do. Like you might have to hold the rudder fully one way for 3 seconds before the motor will become active. So that's another safety thing if you're working on the plane, getting it ready. I just needed to point that out for a reason.
Oh! Oh my goodness. Mayday.
I forgot to arm it. So, but what actually happened there was quite interesting. I intentionally picked that one because the launching setup that I had, and someone asked a question about the bungee cord the last time, so I brought that in. So I've just got about 10 metres of bungee on there with a little parachute on there. You saw the parachute open up after it released. Now, once again, I didn't know what sort of tension to launch the plane at. These planes weigh just over 1 kilo, so I thought, 2 kilos? 3, we have 3 kilos. So I use a luggage rack, a luggage weigher. I pull it out till I get about 3 kilos of tension and then put a tent peg in the ground and all that sort of thing. And that 3 kilos launched that plane right across the football oval. So, and that was with no engine because I didn't arm it. And the launching device, this is a new one which I built. It's just a little 433 megahertz switch and a transmitter and a receiver. I've got this little solenoid on here, so that when you push the button, it just pulls that over, and that's a snap shackle, and that just releases the bungee cable. So just plug a little battery in there, so you can be sitting there, push the button, and just off it goes. And that works quite well.
After you've armed the plane.
After you arm the plane, yeah.
That was that one, wasn't it?
No, it was the C1 Chaser. Okay. So the Easter Challenge, I called it that one because we went to Methina. Methina's a little town up in the northeast of Tasmania. It's where my mother-in-law lives. It's in the middle of nowhere. There's bush and everything around it, and right in the middle is the disused oval anymore. It used to be a footy field back in its day, but now it's just a recreation ground. So I thought, I want to try a little bit of this FPV flying, and these red rings are 1 kilometre spacing. I thought I'd just see what I could do. Now this white area down here, that's an abandoned gold mine now. It's called the Golden Gate Mine. It used to be quite profitable quite a while ago. It's no longer used anymore. So one of my challenges which I wanted to do was fly down around that area if I could. I followed this road flying out here, and I got to about halfway across it, which is 1.5 kilometres, and the video on the goggles and everything all started deteriorating, and I was getting out to the extremity, and then also I think the radio distance or something happened. The flight computer detected that there was something going wrong, probably the signals going backwards and forwards, and it went into a return to home mode. So it just automatically went, something's not right here, it turned around and it flew back, which was really good because that was another thing I wanted to test. When I was coming back, I got control back over it again, and over on the side here is where the cemetery is. So I thought, I'll just fly over there and have a bit of a look at the cemetery. And when I got over there, this great big eagle says, "No, you're not coming over here," and it came and swooped around a few times, and so I left it alone. Then I flew up to the river up there, and then flew back again. So it worked really, really well. So it was such a successful Easter. We had good weather, the equipment worked reliably, and all the fault stuff worked properly. I didn't have any crashes, and I felt like I really achieved something. On the table here is the setup that I had, laptop for doing the mapping and all the information that goes to and from the flight controller. And I'll just point out the little monitor here, which is the one that I've got sitting up here. This, note the antenna. This is just a vertical antenna. Now the antennas on the plane, they're all circular polarised antennas, but that's a vertical antenna, so then that's not quite right. I think maybe that might have had something to do with my video picture deteriorating. So one of the things that I've done is gotten into building my own antennas to see if I can get better picture and better quality on better range. Right. So onto the new stuff. One thing I've had to do, or obviously planes, 2 new planes. These ones are new since Easter 2017. One thing I've had to do is get a new flight controller, and that's it up there. My old one is this little one here, which is called an old APM one. It's now no longer supported. They're not developing any of the software anymore. It started to become unreliable. I couldn't update the firmware or the software, and I just wasn't having any fun. It sort of got past its use by date. So I did a little bit of research, and I come up with this one from Maytech Systems. This is the first flight controller that's been specifically designed for fixed wing aircraft. Normally, and this one here, they're for quad drones and stuff with 4 engines. You've got to go in and change the firmware around or configure it for fixed wing. But this one's specifically for fixed wing. So that's what I've got in the planes now. There's a picture of the antennas that I've been building. This one here is a cloverleaf antenna and a dual biquad antenna. So that's a directional antenna, about 13 dB gain, and that's omnidirectional. I also, the next step with cameras and goggles and first person view, I started getting into head tracking. So as you move your head, the camera can follow where you're looking. So if you're flying along, you want to look over there, you just go like that, and the camera will move around. And I'm going to demonstrate all that shortly as well. Okay. So the planes, I'll just have a quick chat with these. This one here is called, it's pronounced ZOHD, Z-O-H-D, the Dart XL Extreme. It's fairly new, it's only been out maybe 6 months, 8 months or something like that. It's this is the interesting thing about what it's made out of, biodegradable. So I don't know why they did that. Maybe if you lost it in the bush somewhere and you couldn't find it, you could feel safe that you know it's going to degrade in a proper way. Don't know about the batteries and stuff. Yeah, 1 metre wingspan, length 600 millimetres. Interesting, flying speed 25 kilometres an hour, that would be its landing speed. And it's supposed to go 100 kilometres an hour plus. Now I've flown it once, hence it's in really good condition and haven't crashed it. And I wasn't flying at 100 kilometres an hour. It's just a bit of a test fly when I first got it. And I've done a fair bit of work to it in the meantime. Now the recommended battery is a 4-cell battery, which is one I've got here. And weight of about 1.2 kilos, and you get about 40 minutes flying time out of it. It glides and flies really, really well. Okay, don't get all that. And you might notice these little black things on top of the wing. They're called vortex stabilizers, I believe. And from some of the research that I've been looking at, what they do is they create a turbulence across the top of the wing, which gives it a lower stalling speed. That's right, I think, yeah. So it's very hard to stall. Some of the videos that I've been watching of people flying these things, they're just pulling the nose up, pulling the nose up, pulling the nose up. You're waiting for any minute for it to fall out of the sky, and it just gently comes down. It's almost impossible to stall, from what I saw. So the other one, it's called a Tundra, and yeah, it looks more like a conventional plane. It comes with floats, and I've not flown it on the water yet. I've always had the wheels on it, nice big spongy wheels, really good for taking off and landing. And there's optional skis that you can get for it as well, so you can take it off and land it on snow. Now, one of the interesting things about this plane is it's got a glider towing point on the top. And it's so powerful, the motor in this one is so powerful that it can tow a glider up, and then you have some release mechanism. Now, the motor that's in here, when I got this plane and found out how powerful it was, that's the same motor that's in that one over there. So when I converted that one to electric, that motor is one of these motors in here. They're just so torquey, and the disadvantage about it is it draws so much current that you don't get anywhere near as long flying time, and it does use a smaller battery, a 3-cell 2200 battery. So, and another interesting thing, it has a reversible propeller. So why would you want to turn the propeller backwards? Anyone want to have a go?
Slow down for landing.
No.
Reverse on the water.
Reverse on the water. Yeah, if you're landing on the water and you go across a lake or on a river and you get stuck, and it's or in the middle of a lake or on an obstacle or on the other side of the river, how are you going to get it back? So by reversing it, you can reverse off and come back. It's got, I don't think I brought it with me, but it's also got a little a rudder. You take the wheel off and you have this little spade that sticks down here, and as you turn the rudder, you can steer as you're taxiing in the water. Yeah, and obviously the camera that I've put on the top, which I'll be demonstrating shortly. Yeah, I think that's about it. Oop. Okay. Right, now this is a block diagram of how it all fits together. And this was a diagram I used on the last presentation. Even though this is this flight controller here, the new flight controller is subtly different. I'll point that out as we're going along. So you can see the flight controller in the middle of the APM there. It's basically the brains of the whole thing. This is what's all sitting in the aircraft. You have your receiver receiving at 2.4 gigahertz. That all gets fed into the APM flight controller along with the GPS. Now the GPS on this one, and it was a question someone asked at the last presentation. I had a great big GPS sitting on the top. And they said, wouldn't you be able to put it inside the wing or something? Well, this model comes with recessed positions where you can install stuff. So it's built really, really well. So the actual GPS is sitting in there. And it comes with little channels where you can run the wires in through the thing and into the bay in the middle. So it's built really, really well. So you've got your GPS information being fed in to the flight controller. You've got telemetry at 915 megahertz through this antenna here, and there's another antenna that sits on the laptop. And the FPV camera, the first person view camera, feeds into an external on-screen display. You get digital information coming out of the flight controller, mixing with the on-screen display and then going to the video transmitter, being transmitted at 5.8 gigahertz. And the reason why you've got that is so you've got all your flight data, your altitude, speed, battery, gets information from a voltage and current sensor which is fed into there. And then the flight computer controls the motor. So depending on what's happening, you can program it to return to launch at a certain speed or altitude, and everything's all programmable in it, and it's quite complicated. Also a lost alarm for if the aircraft lands somewhere and you've got to go looking for it. There's a new one that's come out, which I haven't, it's called the Fly Finder. I saw these advertised the other day. It was $20, which I thought was pretty good. And it's got its own battery in it, which is a good idea, because if you have an accident or you crash, sometimes the battery's ejected from the plane and it's no longer going to work. But this has got an inbuilt battery. So if the battery gets ejected, if this loses power, it starts to alarm, and it gets louder and louder. It goes up to about 105 decibels, so you can go and find it. And at night time, it turns off. So it's not going to annoy someone if it's near someone's house or something. And it has a really bright LED on it, and the LED flashes at night time. So if you can't find it during the day, go back in the dark and you might see it flashing up in a tree somewhere or whatever like that. So I thought that was really good. There's a bit of smarts in there. The new flight controller is being more modern. It's got the on-screen display is built in. The voltage and current sensors all built in, and it also runs what's called a serial input, whereas as you can see I've got like a parallel input coming from the receiver. That's got the 8 channels coming out of there going into there. So because I've still got the same old receiver, I've had to use a little parallel to serial converter which is sitting in the plane. So the receiver goes into a parallel to serial converter, and then the serial information goes into the new computer. Okay. So this is the new computer with its with the top of it off, and just a bit of a block diagram of how everything all connects. And you can see the battery goes directly onto it. The camera goes directly onto it, and then the output goes into the video transmitter. The telemetry, they've got a Bluetooth module here, but that's where the telemetry hooks in. GPS hooks into here, and the receiver then hooks into there. This has got a buzzer output and a programmable LED. You can, if you want to monitor any fault codes or anything like that, you can set it up so it get a certain pattern on there. It also supports an OLED, which I haven't looked at doing yet. But that's how the new flight controller works, and it's around about $60, which is not too bad considering everything that it does.
It's the kitchen sink, right?
Yeah, so it's just amazing. And one of the good things too is this new flight computer supports the same software which I was using before on the laptop, so I didn't have to learn a new software package.
Can I just, where is your output for your servos?
Yeah, there. Yeah, servos. Sorry, I should point. So, and
yeah,
because I'm using a wing, it's the flight computers in this one. I only have 2 servos.
Right.
Yeah, on this one. There's no flight computer in in the Tundra because it flies really well without it.
And that shows 2 electronic speed controls?
Maximum of 2. If you've got like a model with two, I've only got single engines, but yeah, so it can support up to 2. So it's not designed for a quadcopter. Okay, so that takes us to antennas. Now there's that picture again of the vertical antenna there. Yeah, the picture quality got really poor, so I thought I'll start building my own just to see how I go. And I've got the double bipod antenna here, and I also went and purchased a little patch antenna, because one of the things I want to try and do is try and get longer distances and get better video quality. It's a bit of a project which I'm working on. I'll talk about that shortly. And I've just listed some of the frequencies that this uses. First person view, the video is 5.8 gigahertz. The transmitter, 2.4 gigahertz. The telemetry, 915. You can also get a 433 megahertz model. It's got GPS in it, as I mentioned, and there's a whole string of those frequencies. I think you rattled them off last time, Justin. 1.5 gig or 1.2 gig and all sorts of them. My bungee release that I designed, 433 megahertz on there, and Bluetooth, which will come into the head tracking stuff in a moment, runs at 2.4 gigahertz as well. Right. Now, next one. A bit of a discussion on linear polarized and circular polarized. So with the vertical antennas, you've got your linear polarization. So when you're transmitting your signal and when it's being received in an antenna, one of the disadvantages with linear polarized signals is when they bounce off objects or take a longer path, multipathing, and they end back at the antenna for the receiver, you can get positive going signals, negative going signals, and they can cancel out and cause dropouts, and maybe that could have been what was happening that I was experiencing on this little monitor, which actually records video as well. So circular polarization, using the circular polarized antennas, when you've got a left-hand rotating wave or a right-hand rotating wave, you get your direct wave coming to the receiver, might be left-hand polarization. If that wave bounces off an object, like a building or a car or off the ground or whatever, the polarization reverses. So you have a direct left-hand polarization wave bouncing off an object will come in and be right-hand polarized. But because these are specifically designed to only receive one of those polarizations, left or right, it has about a 20 dB rejection for the other polarized signal. So it eliminates more of or reduces the multipathing effect. So building these antennas, as you can see, they're quite small, and we're talking about tenths of or hundredths of millimeters in measurements and angles. You've got to get the angles right, you've got to get the length of the wire right and the bends and all that sort of stuff. I was using a digital vernier to measure the lengths of the wire. You've got to take into account the width of the wire when you're bending it, because if you don't and you end up with a one wire length too long or too short, well, that's going to affect the frequency. And the diameter of the wire, the thicker the wider the bandwidth, but the narrower the wire, the narrower the bandwidth, which if you can make them really accurately and have narrow bands, it'll work better at that. So you can see they've got to be quite accurately made. I looked at a couple of DIY sites on how to do it, and some people were saying get a blob of blue tack, put it on the table, bend your wires up and poke them in there and start soldering them. So that's all right, you can get them soldered, but then you have to work out the angle, sort of guess the angle of 45 degrees, and this angle going around here. So, and then when you go to solder your coax on, this is RG402, semi-rigid coax, you can bend it around. When you go to solder that onto 3 wires, well, of course, they'll all fall off. You end up trying to hold them and burn your fingers, and it's just didn't work all that well. So I gave it a bit of thought. Now, my first couple weren't that good, and I thought I've got to do a better job here. So I came up with a little jig, and I made 2 jigs. There's the cloverleaf one has got 3 little lobes on it there, and the skew planar one, which is a 4-lobed one, I've got 4 of them on there. Now I've fairly accurately cut these pieces of perspex and glued them at the right positions, so I've got my angles going around, I've got them right, I've got the 45 degrees right, so you just cut your pieces of wire and shape them. Just hold them on the top with a little bit of blue tack just so they don't fall off, and you can get them really, really accurately set up. So you can solder the bit in the middle, and then there's a hole in the bottom, so you poke your wire up the bottom. Once you've trimmed set the center conductor and everything up okay, it'll hold in the right position. You solder it on, nothing falls off, and when it's finished, you just pull it straight out, and you have your antenna. So you can make them really quickly, and you can replicate the accuracy. So I thought that worked really well, and I hadn't seen that anywhere else on the internet. So that's a pretty good idea, that one. So I might hand them around if you like, and probably them as well. Okay. So I found this slide, which was interesting, and I learned something out of this. So here I am, sort of bagging out linear polarisation, thinking, why would you ever use that? You just stick with circular polarisation. But when you use circular polarisation is when you're flying close to large objects, trees, buildings, enclosed environments like car parks and stadiums. Now you may have seen drone racing. They have these things in car parks. So they're flying around inside these concrete walls all around them. They must get reflections like crazy in there. So that's where the circular polarisation antenna is going to work better. Acrobatic flying. If the aircraft is going all over the place, upside down and all that sort of thing, circular polarisation is going to work really well. Linear polarisation not so much, because you can imagine if the plane's horizontal, you're going to get your linear polarised going to your linear polarised receiver, but then when you're flying over on the side, this is going to turn horizontal polarisation, that's going to be vertical polarisation. That's not going to work. So that's where circular polarisation works better in that area. But then linear polarisation, if you're not doing any wild flying around the place, you're just flying stable around, you just want to go for a nice long fly out and back again, that's where linear polarisation would come in handy. And as you can see, these antennas are pretty fragile. So with this one, you know, it's fairly strong, but you probably wouldn't want to flick that because you'd bend all the wires and all that sort of thing. So that's where they have their advantages and disadvantages. A little bit of a picture of a left-hand polarised antenna and a right-hand one. You can see they're poorly made too, not as good as these ones. You can see the way I remember it, when you look at it, if the radial is to the point upwards to the left, that's a left-handed one. If it's upwards to the right, that's a right-handed one. And you've got to use the same ones all around. And a bit of an example of what the video signal looks like in the goggles when it's going bad. And that's no good when you're flying along looking for things and then it goes like that. So it's fairly important to get it right. 20 dB rejection from left-handed to right-handed polarisation.
Do you have anything like a minimum altitude or a minimum setting above ground level so that you know that you're not, until you get control of it, it's not going to go below 30 metres or something like that?
Geofencing.
No, with regards to the video picture,
well,
are you? Or?
The plane itself.
Yeah.
A fail-safe minimum 30 metres.
Oh, right, okay. Yes, there's the more technical side of setting up with the flight computer. You can set, because it's got GPS on there, so and a little barometric sensor on it as well, so it knows what altitude it is, and you can actually set it so it won't go lower. You can flick a switch so it will not go lower than that altitude. If you're teaching someone to fly, you hand it over to them. If they lose control, well, you know that it's not going to crash, because as soon as it gets down to that altitude, it'll level out and then just keep flying, and turn around and come back if it goes too far away. I haven't done that yet. That's on the list. And if everything's right with the build of the antenna, it should look like that, which you're handing around. Thanks for that wire too, Justin. That's your red wire.
Have you got a way of testing those?
I haven't, because it's such a high frequency. Yeah, there's. I did see a couple of suggestions on how to test it. It's go out and buy really, really, really expensive antennas and use maybe an RSSI signal on a receiver, and then put your antennas in there. Use one as a reference, and then put yours in there and do a comparison to see if it's any better or worse. That's really about the only way. I was just going to eyeball it. So I knew where I could fly before when the signal started to break up, so I'm yet to go back there and see if it's any better.
Just looking at that, I'm wondering whether there's any correlation between that and the typical marine prop.
Yes.
Turning that round looks very
similar
to the way the prop would.
Not very efficient in water though.
The angles might be somewhere similar.
Yes, yeah. So this is a double bipod antenna. So I got this off the internet, and I've got references at the end where I got all this information from. So that's got about 13 dB gain, and they're just made from single-sided PCB. I just printed it out onto paper, ironed it on the printed circuit board, and then etched it. And I'll get you to pass on. Two of them both the same. Yeah, and the reason why I built these was because I want to get into some form of higher gain. So these are not circular polarised, they're either horizontal or vertical polarised. So I'm sort of working on an antenna tracking system which will track the plane and hopefully keep these focused on the plane as it's flying along. So when you're a long distance away, you'll get a better signal. So that's why I started building these. These are much easier to build. As long as your photocopier doesn't distort the size, because the size is important, you really only have to get the distance between the element and the reflector fairly accurate, and and away you go. I haven't tested that one yet either.
There's one on a website. I saw a modification done onto a transmitter not for this particular, but for ordinary model aircraft, using a double Moxon antenna, and that might be something worth looking at.
Not sure what that is, so
okay.
Talk about it later. Alright. So now head tracking system. My initial testing with the head tracking system, because I've got so many controls on the transmitter, I do have two variable resistors on here. So I thought I'll pick a azimuth and an elevation. So I just wired up two channels to azimuth and elevation, like the one that's on the Tundra over there. And as you turn these pots, you can adjust it in azimuth and elevation, or pan and tilt. And that works quite well. The only trouble is, if you've got your goggles on and you're flying along and you're controlling your aircraft by moving these sticks around, and then you want to move the camera, you've got to take your hands off the controls, fumble around till you find it, adjust the camera, and start getting into trouble. You've got to take it off there, come back, and then try and get control again. If the camera's skewed off at an angle, it's not going to end well. So I thought, nah, that's no good. It works, but it's no good. So my first version of my head tracking system, it uses a little Arduino. I got this information off RC groups, off a blog, and uses a little Arduino under here and a gyro sensor board on top. And this is a wide version where it plugs into the back of the it's in the buddy port, so you can connect two of these transmitters together. So if you've got like transmitters, or if they both support this buddy port, you've got a trainer switch where you can flick it over, and you can have the other person could be flying, and you flick it back and you take control when they get into trouble. Now this works on the same principle, but only two of the channels, pan and tilt. So that just gets power. Now this wide version, you put it on your goggles, and it works quite well. And I've got a little video of that which I'll show shortly. The only trouble is you're tethered with a cable. So this is on the goggles, you've got a cable going down to the transmitter. If you put your goggles down, or if you want to pick them up or whatever, you've got this cable that's getting in the way. You put the transmitter down. If you've still got the goggles on, you've got the cable stuck. So I thought, well, that's no good. And a little bit further in the blog, they went into a Bluetooth modification. So this is a block diagram of what I just showed you here, where they have the Arduino, the gyro sensor, and the cable going off to the transmitter. Now this is the Bluetooth version. So you have, this is on the goggles, you've got your Arduino with your gyro sensor, Bluetooth module sitting over there, and a little switch, which I don't think was on the other one, but it's got a switch on it, and then it just gets power. So I've gone and built that in one of these little Wi-Fi boxes, kind of spare box. I've got my little Arduino down there with the gyro sensor, and you can see the Bluetooth module over on the side, and it just gets power from the battery. Now the switch, when you first put the goggles on, the camera might be a bit skew-if or whatever. You push this switch once and it centers it, just puts it 0, 0. So that's really handy. If you happen to turn your head, or if you adjust yourself and the camera's a bit funny and you want to just push the button again, it just centers it again. So it works quite well. If you hold it for 3 to 5 seconds, it'll freeze the camera motion. So then you can move your head and it's not going to go anywhere. You probably do that if you're coming into land or something where you don't want to move and go off on a different angle. So, and that works quite well. And the receiver side of it, it's the same sort of thing, another Arduino with another Bluetooth device. Now you need to configure these in master slave, and you need to configure them, which I didn't know any of this till I researched it. You need to configure them so as soon as you turn it on, they automatically bind, and you want to set it up so no one else can jump on it as well, because if someone gets on their phone and turns on Bluetooth, they can hook into here and cause all sorts of havoc. So you can secure them with a pin, you can secure them with the ID of the other, like the MAC address, so it can be really well secured. And what I did was built it inside the transmitter. So I've got the Arduinos over on one side, the Bluetooth on the other side, and I'll put the little button on here, which is this one here, so that if you've got your goggles on, if you wanted to send to the camera, you don't have to take your hands off the controls and push it, you just push the button on the back. So you're flying along, push the button, it just centers it. So, and that works really well as well. Right. I think that's it. Right, I'll give you a little demo of that. So we'll start off with the Tundra. There's a whole series of steps here. Turn the transmitter on. Now, because I'm using the same radio for two models, I have to choose a different model on it. So it's currently selected on this one, so I'll go over to there. And a safety thing, if we're going to be powering up a plane, we'll take the propeller off it. So we won't have any accidents. Power up the battery. Now we should be getting a picture. Yep. Now there's my little plug, which was like the other. I've got to plug it into the thing. It's all working. So now if I pick up the goggles, as we turn the goggles around, you can see the picture changing on here. Oops, stay there. So we can look up, we can look down, we can look fully to one wing and fully to the other wing. And if I'm standing this way and I push my centre in, it goes back to centre.
I'm waiting for the port to come up and shake hands with you.
This is these little cameras are really good because it's inbuilt transmitter. It's all self-enclosed. You've got camera, transmitter, the whole lot. So you just need to apply the servo power and the power for the camera. It's good. Whereas this one over here, there's a separate video transmitter and everything. So they're quite handy. And we made one for reversing camera. So you sit this with a magnet, a battery and a magnet to stick to the back of your car if you don't have a reversing camera. and just sit the monitor in the front, and as you're reversing you can hook up to your trailer, and that works really well. So that's that one. Change over models. Remember to take the propeller off. That's better.
Just under there, I think, near the batteries.
There. Right, big battery here. Sit that down there. So, now there's no tilt on this one. It's just pan. Now, it's probably not moving. That's because the front camera's on at the moment. If I flick the switch, the video switch switches in there, and now it should be moving. So we get wingtip to wingtip. Alright. And zeroing. That all works.
Backwards then.
Say again?
Is that backwards then? As to which way you're
It
turning?
is backwards. Well spotted. I was wondering if anyone would notice. So what's actually happened, the way I've got this set up, the servo over here is upside down. So, and I've lined this one up so it works right. But this one here, as Neil pointed out, it's actually the wrong way because the servo in here is the right way up. So it is configurable with the software. You just have to tick a box to say reverse. And I had to pick one of them. So, okay.
Don't stand on the colour.
Yes. I'm going to do that. Unplug that. Okay. And I put a little battery monitor on the back here so I can keep an eye on how the voltage is going on there. So I think that's like $2 from China, free postage. Okay. Plug that. Right. So I've got a little video of the head tracker in action. So, there's no sound on this one, there's no sound, but this is on the oval and there's the ramp over there. And these black things on here, I've got black straps on the front of it, just because I wasn't sure whether it might blow up. So I put some straps on there just to hold the front down. You can see a bit of the propeller distortion there. Now because the camera's so far away, it's not that bad. You know, you can put up with it, but when you've got the camera close, so there we are, just down at the car there. Now, from what I've heard, you can get very disorientated and so saying very short video.
Show it off a bit.
I haven't got any loops on this one. I've only got rolls.
This is the one where the kids had the goggles
Yeah.
on?
Yeah. A bit of upside down flying, and then I come into land. So I tried setting that Vasi box like here when I come into land through there, but just couldn't see it. Landing. So you'd probably lock it at this stage. You wouldn't want to be looking around when you're coming into land. And this is with wheels.
Do you find that there's a minimum distance you have to be out from your landing spot to get yourself set up and check your heights and things like that?
A bit of practice to get in the right position for landing. Yeah, that's fairly important. I'll just pause it here in a second. Right, and as Neil mentioned, oh, stop. Oh. I'll just go back to there. Stop. It's not going to stop. There. So I didn't have the goggles on. These two kids down here, Jack and Oliver, they were sitting on the ground with goggles on. So I think their legs are getting a bit wobbly when they're standing up. So they were sitting down, and I've got a couple of sets of goggles. So one had the head tracking one on, and the other one was just the passenger. So, and they were sitting there watching it while I was flying it around. Yeah, so with regards to your question, I found a spot. There's a road that comes out. I know if I'm flying over that road, this is where the Vasi thing would have come in really handy if it would work. If I'm 50 metres above that road with goggles on and I'm heading towards the oval, it's the perfect position, like an outer marker. It's the perfect position to come in and do a really good landing at the right angle and everything. So, yeah, you sort of need a bit of practice at doing that. Okay, F11.
Or you just find a tree.
Find a tree. Yeah. Right, now what's next? As I mentioned, I've not flown this on water yet, so I want to be able to fly it on water. I want to do it that way, not that way. I mentioned about the directional antennas. I built a little antenna tracker from another project, uses Arduino, this is prototype one, and has azimuth and elevation servos on here. I've not had a lot of success with that. It's sort of been inaccurate or doesn't track it properly. Yeah, there's a fair bit involved in there, so I'm still working on that one. And of course the last thing is to have fun, which takes me to my last video. And that's that aircraft you can see over on the left there. So that one that's flying there, that's that one. Oh, not specifically that one, but the same one. Defies gravity, doesn't it? They have so much thrust with these little engines. It's spinning so fast. There. Right, and there's a few references for some of the stuff that I've done, and that's it. I hope that was entertaining.
Questions for Ron?
I guess the one is where you fly, whether you have insurance, and things like that.
Yeah, it's I don't, because of the remoteness of it. Yeah. So I'm out in the bush. The worst thing's going to happen, I'm going to crash into a tree or into a paddock or something like that. So, but I do have intentions of joining a model aero club for insurance and flying with other people. So that's another thing which I'm yet to do, but that's on the list. Yeah.
What's the all-up flying weight of one of those?
About a kilo, 1.2 kilos, something like Yeah, I think that was 1.2, and yeah, they're about the same, about that area.
What about the,
Yes, that thing there, it's got nothing to it. It's called a foam board thing, as you saw. There's no technology in it whatsoever. All it is a battery and a receiver and 2 servos. So the push rods, the reason why they're so manoeuvrable, the push rods control both surfaces, the aileron and the and what they're set up to elevons. So when you go up or down, you can see it's there's a fair bit of angle with those 2 surfaces. That's why they can go straight up and then straight down and all over the place. And they're so light, and this little motor spins this. It's so loud when it's going, and just heaps of thrust. I think the body acts like a speaker. I think it's vibrating with the sound of the motor and all that. And like the first time I took it off, there was a couple of kids standing around. I just revved it and threw it, and the noise that it made, the kids turned around and they ran away, which just scared them. They're not hanging around there, but yeah, it's just crazy.
so what sort of revs is it running at?
Oh, I can't remember. That one revs a lot higher than these ones. It's
12,000? These are 12.
Yeah. I can't remember. I could look it up, but I can't remember exactly what it is. It's
You have to
pretty
stop
fast.
the engine when you land, do you? Because the
Yes.
stop.
Yes, that's right. Yeah.
And does it stop in the right place?
When it doesn't, there's a little bit of a mod that I did that I got off an idea from someone else.
Oh,
Just cable ties, because it's normally flat.
Yeah.
But having the cable ties on there, it's lands a bit better, and a little bit bouncier too. So this one here, there's no wheels on it, and when the propeller's on it, it can, if it's in the wrong angle, you can break it off. I haven't flown this one enough to do that yet, but the other one that I had, the one that was on the ramp, when I first started doing, I was breaking propellers quite regularly, but after a bit of practice and making sure the throttle was right down to 0 when you're landing, timing the landing properly, I was going for ages without breaking the propeller. I went flying last weekend and broke a propeller. But I think it was $1.80 for 6 propellers. So I've got a heap of them, so it doesn't matter.
So Ron, what sort of airspeed do you get out of that plane?
Yeah, this one, it's meant to fly at 100 kilometres an hour plus, which I haven't done yet. I've only flown it once, and it was a bit of a practice fly just to see how it went. But yeah, there'd be, I think there's a few YouTube videos where people have done a few mods on them. One thing I've noticed is the wing surf, the elevator, or elevon, it's a little bit sort of soft, so that at high speed these would probably flutter, which wouldn't be very good. So I've seen one of the mods is they take these off and they use balsa wood, replace them with balsa wood, which is a bit stiffer, and a few other strengthening modifications to it to make it fly a bit better. It only comes in like 1, 2, 3 major parts. I think I may have brought the assembly instructions. 20 minutes to put it together when it came in. It's just like, it's all made, servos already installed in the wings and everything, motors already installed, so it's really, really easy and quick to put together.
So what's the scale speed?
I don't know, haven't worked that out. Yeah, it'd be pretty fast, I reckon. Yeah. Next time round, I might be able to get a bit of footage of it flying and get the speeds that I can fly at, because it's all recorded on the on-screen display and all that. So I've only just put the flight computer in it recently. I flew it once without the flight computer, and then decided I prefer to have a flight computer in it, a flight controller, but I haven't flown it since because I've been busy getting it ready for this presentation. Right.
Any other questions for Ron?
Yeah, Ron, the video clip you had, that one there flying, that looks like it was Lathina, I think.
Yes, that's correct.
Did you land that with the goggles on?
No, that one I didn't, because the kids were wearing the goggles. Yeah. I haven't, this is fairly new, this setup, and I haven't done much flying with goggles on that yet. Well, actually 0 with the pan and tilt, because I built it, came in those friends from my wife, they came along on the Saturday, and we went flying then, and it went all really, really well. And then I ended up running out of battery, so went home, came out the next day, they left, I came out the next day by myself. First landing, it rolled over, and just the antenna just got squashed. So I didn't have another one, so that was it. So, yeah.
Now you had to wire the camera and its mechanism up separately. What sort of wiring did you use? Anything special?
No, it's just it's a normal radio control wire that comes with servos and stuff. You can buy just 3-core wire because this is a self-contained unit. And see, just on that, when I bought it, it came right-hand polarised, and there's the antenna that was originally on it. And they're right-hand, because you see they're sloping to the right. And everything I've done here is left-hand polarised, so I unsoldered it and then made up my own with the jig and then just put it on there and soldered it on. So I've replaced that that antenna with a left-handed one.
With your hand control, have you ever considered microsurgery?
No. Okay.
Cool. Show our appreciation of Ron's.
Yeah, very good, Ron.
By all means, go up and have a look and...
Yes. Did you want to talk about your...
No, I just brought it along.
Right, okay.
Somebody to look at. That's
Yeah.
all. A technology when I was a kid.
Yeah.
The layout of your hand control, does that go to a set sort of pattern, or is it you worked out your positioning yourself?
On this, yeah, there's 2 modes, because 3, 6. I only know of 2. Because I'm a bit old school, learning back in the 70s, back then they call it mode 1 was the most common one. And mode 1, this is the throttle on the right, and you have your ailerons. So basically your primary turning control is on the right hand side with your throttle, and over on the left is your elevator, so your primary up and down, and you can have rudder selected on there, which is also turning, but you normally turn with your ailerons, bank over with the aileron, whereas the rudder will cause the plane to yaw, because the rudder on the back here. Yeah. I'll power that up.
But I was thinking of all the extra switches you've had.
Yes. Well, that's basically up to you what you want to do. All the different modes, which we didn't go into in this presentation, there's 6 modes, and that's this little piece of paper on the top here. So fully on the left, that rotary, I put a rotary switch on there. So that's manual control. Whatever I do here happens there. The next one, when I rotate the switch, it's fly-by-wire A. There's a fly-by-wire A and a fly-by-wire B, and they're subtly different. Fly-by-wire A, it basically gives feedback. So if the plane's going along and a wind gust blows it over to one side, the gyro and everything in the flight computer senses that, and then puts all opposite aileron to bring it, so it keeps the wings level, so it makes it fly a lot more stable. It's easier to fly in that one. Position 3, loiter. So if you're flying along and you want to check something out, which will be really good with this pan and tilt, you flick it to loiter and it'll just fly in a circle. Wherever you are, it'll just fly in a circle. I think it maintains the altitude that you're at. Cruise is another mode. There's a whole heap of them, and I've just picked 6 of them. So if you're flying along, like when I showed you the Golden Gate mine and the river, and you go, I want to go to the bearing, you can turn the aircraft onto the bearing, flick it to cruise, and then take your hands off it, and it'll just cruise there. It'll just keep going in that direction. And if wind comes along to blow it off track, whatever, it'll correct it and then keep going. That's just all the flight computer stuff in there. Auto tune, it's a way of fine-tuning the settings in the flight computer. When you start off new, you need to tune them all up. And the final position, return to launch, so I've got that hard right. If something goes wrong and I want the plane to come back to me, go return to launch, it'll turn around and come straight back because it knows where it started from, and it'll come back to you and it'll circle and your predetermined height and radius, and it'll just stay circling until you put it back into another mode. Yeah, and you just program the switches. I think that switch was, I set that up for the switching of the video camera.
But it comes with most of those switches inbuilt.
Ah, yes. Yeah, the only thing I did to that was put that a rotary switch in there instead of a normal switch, because I wanted the 6 positions on it.
So is your overall range for operation improved, or where you were last time? I remember last time you said you were running signal.
I haven't got there yet, because all this is fairly new, and I need to do another Easter weekend and just do the whole thing, which will probably be, or the next time I get the opportunity. So I want to try all the different things, more with the head tracking and this new plane, which I've only flown the once. I want to try it with the flight computer and do some of the stuff that I did with the other one. Yeah, the other thing I'm going to have to try and work out is the other plane had a launching hook. This one doesn't have one, so I have to manufacture some form of a hook, pick the right spot to launch it if I use the ramp, that is. Because you wouldn't want it too high and you wouldn't want it too low. You have to get an optimum position to launch. So I'm not sure where that is yet.
Weren't they guys launching it by holding it? Is that the one that they were holding it?
Yeah, that was
He
the
also smashed those,
boomerang
didn't
way.
And does this type of aircraft lend itself to photographic work like the rotaries?
I think it can do. It's not
Obviously
something
you
that...
might have to bring the speed down a bit.
There's another optional extra with this one that can hook up under the bottom without floats. Is they call it a lolly drop. It's a large sort of canister thing there which opens like bomb bay doors. You can put things inside there and push a button and it'll open up and drop things. So you could mount a camera and stuff if you wanted to. But there's probably more suited models for camera work than these ones.
Fantastic.
Okay.
Thank you very much, Ron.
Right.
Grab a coffee and have a look up close and personal.